Hey there. I'm going to call this video something like uh, don't don't hide your bugs, fix your bugs, something like that. Or knowing when you fixed a bug as to just having hidden it. Yeah, but first things first. You know, you know what started me on this uh, particular bug hunt was this file open dialog, which, here we go, control notify. Now this is the list. You know that dialog I have for this program? This dialog? It's actually resizable. Dear, I know what that is. But it is resizable when it's not in, even when it's in debug mode. Once you fix that bug, here it is at a different size. This isn't exactly what I wanted. I want this to work. It doesn't work in this version. But more to the point, first let me fix this one thing. When the list selection changes, and it's not a drive selection, stir result, and dialog cancel. I don't know what that is. I want to put something in that little box there. Max file. This is the code that I was using as for a hook, right? Where I was using this dialog to replace the real open file name dialog. Okay, now here, file offset. Here I'm working out what to put in for the various fields when you want a successful selection of a file. So here, stir file, and what I'd like to do is set the text of, I have this in TS Windows, this dialog. Now that I'm using DLLs, I can put dialogues in my libraries. You can't do that with a lib. You have to use that trick that I was using. Which you can still use that trick, but you don't have to. This block, which is called, I should turn this into one of my edit controls. IDC edit file curve sound. So I should do this here. And I should put in there, really, I should put in what's going to go in the destination. Will that work? And the reason is, I went back to rebuild. I'm rebuilding my programs now that I've changed everything to DLLs. And one of them is my graphics editor thing. Initially meant for discussing and demonstrating the use of those Hermite curves, those splines. The various splines in the world are almost all, fall into the category of the cubic spline, and the one that's used is called the Hermite. The Hermite spline, I guess. They have various names, like the Catmull-Rom spline and the, I have them written down here. Funny splines. Oh, we need the header file. Here, catmull-rom, cardinal spline. Yeah, that's the one. They're all part of this family of curves. But this family of curves is just a special case of this family of curves, called a Hermite curve. But anyway, I was getting a memory leak. Now what I can do is I can put it's easy for me to interchange this. What I wanted to do, because the memory leak was occurring only in certain scenarios. Now where do I load? There's a place where I load, like open file. Open file name. Here. Okay. Let me show you what I had and why I was suspicious. Okay. Oh, image control. That's not important. Open file. This is what I had originally, which I have a special wrapper around the open file name function. It's a class that acts like a dialog. You add filters and it's quite easy to use. You say do modal, and if the result comes back okay, then the result gets stored in this string, and then you do whatever you do with the file. Then I ran my program, like so, and amazingly it ran. I changed the runtime libraries and everything. Got rid of things I didn't need to link to. Even found out wallpapers and so on. Open up wallpaper. Oh, hey, this is using my new one. Oh, because I didn't change. See, this is using my fancy dialog. But if I open a file, this is using the regular Explorer style dialog. It does come up eventually. Oh, there it is. Okay, now Allen 0. Let's suppose I didn't have these at the time, so let me open up something I did have. This. It's an ellipse. Exclaim, exclaim. Yes, it will come up. There's a lot of stuff in this particular file. Okay. Now I close the program, and I'm getting this memory leak. Okay. First, I had some memory leaks, and I found them right away. There were some simple ones, obvious ones. I can't remember what they were, but obvious enough to fix. But these memory leaks don't have a file and line number with them, right? Now that indicates a bug, okay? It's something to do with a memory leak. There's a bug going on, and the fact that this is not showing me a file and line number indicates that it's not a memory leak problem, but a bug indicates it's a bug. Well, I tried to narrow it down. First thing, what I wanted to do, because now that I'm using the DLL version of the runtime library, when I do something like this, okay, and you take a look at what gets loaded when I load up this dialog. It's still loading. For one thing, like, what's this RPC server? You know, that's unavailable for. And look at all these things. Setup API, Explorer Frame, Windows Codex, Dropbox. Here's Visual Studio 9 runtime. Okay. And obviously some of these things are going to be using the DLL version of the Visual Studio 8 runtime, and possibly some the debug version, which was what I thought. I want to eliminate that possibility and stop all this nonsense anyway. What do I need Internet IE proxy for? And search folders DLL, and Wintrust and NetUtils and portable device API, right? Uh, link info DLL. And what's this RPC server thing all about? I tried to track that one down. In fact, what I did was you can find out when that's happening. See, because I haven't broken into the program, but you'll see. What I want to do is break on one of these exceptions, right? And you can do that the following way. You go to exceptions. I don't know if you have to be in the debugger or not. And look for the category that you think it might be in. And I thought it might be in this category. It turns out it is. Okay, now watch this. I'll start over again. I want to know what's trying to make it a remote procedure call. And you'll see, I'll get an exception. It'll break into the debugger when it hits that exception. It should. Oh, I'll hit the wrong thing and get the right set down. That's not it though. Reset. So it's native, I guess. No. Well, it must be a Win32. Try to open a file. Okay, now I've hit an exception. And it says show disassembly. Okay. Here's the exception where an attempt to acquire an RPC server is being made. And if you look at the threads here, right? That thread. Oh, before I didn't show this thread last time. I couldn't even see it. But which thread is it? This here it's not a multi-threaded program, right? It doesn't use any extra threads. All these other threads are coming from the dialog. And this one in particular, which is that 755B something. I don't know if I have it listed. It's not crypt32, I know that. It's been loaded prior to program load. It's one of these. It's probably this server client DLL, which if I did another listing like this, I could find out where it is. And you can be sure it's going to be here, right? And I don't know what this function happens to be. So I don't really want any RPC servers to be loaded up in my program either, right? For whatever reason. What is the reason? You know? What's this ELAN tech? I thought that was something to do with my mouse. You know, I have a laptop and it has a mouse pad that you can move the mouse with your finger. And I don't like that because I'm always touching that thing and it's always clicking and doing stuff on its own. So there's a little utility, which I don't see it in here anymore, called ELAN Tech, and it allows me to turn that thing off. Well, okay, fine. Explorer frame, app help, Dropbox gets loaded in. I mean, there's a bonanza going on here. And that's just the start of the show, right? EH store shell. Who knows, right? I imagine this is server client. If I keep running, it hits more of these. XML-Lite. Okay, another crash. Same crash. NetUtils now. Network Explorer. IE frame. IE proxy. Okay, so now we need to install proxy. Structured query. RPC RT remote. So this is the RPC, the installing of an RPC DLL, but still some kind of server is not available. What's the server for? I don't know. But it keeps trying and trying and trying. Now we're at, this thing's trying to get hold of the RPC server. WMASF. You see what I'm saying? I don't like that. In the first place, that's a bad thing. But in the second place, reset. I do want some of these on. Access violation, at least. It's possible that some of those millions of DLLs might be using my runtime library, and maybe I thought maybe the memory leak might be coming from one of them, right? Because it doesn't have these memory leaks don't have, if they were allocated in my program, they should say the file and line number. Should, unless I have a bug, right? So I thought, well, I already have that thing in dynamic. It does pretty much file, it covers file open. I just need to fix a few bugs. So I went and my thing that wraps the file open dialog itself is in here. And I didn't want to put that code in here. I like to have it in the Windows specific part. So instead, and I don't want to add a new dependency, so instead what I did was I added the ability to pass in a pointer to a getOpen or getSave file name function. The header file here, or getOpen file name. Where are you? Here. So I might as well colorize this. This is a get open file name or get save file name function, which both have exactly the same prototype. So it's get soften. Like my soften cust lib, it is a bool API entry star taking a LP open file name thing, and there's no default in the root class here. It has to be provided, and the things that use that root class, like open file name, you can either specify it, or if you don't specify it, it passes in the default get open file name. Okay. Then I made my function over in TS Windows, which has exactly the correct format. Let's say bool when API entry function taking an LP open file name structure, and it uses a dialog that I made. You saw the reasons for it here, and now I'll change it back in the program to use that. Is this where I changed it? Yeah. So now I'm passing in, I want to use this open file name function instead of the load the universe one. You know, load up all of the entire operating system just to open a file. No thanks. I'll just go with the regular one that I made. I figured the memory leak would disappear. I figured it's got to be one of those stupid DLLs. All those millions of things loaded and dozens of threads started and RPC server exceptions being thrown and everything. It's got to be one of them. But nope, you'll see. Still got a memory leak. The same leak too. Without any file line number. This is at the point where it starts getting depressing because I don't know where to look. And in fact, yesterday and the day before, I tried a lot of things and I still didn't know where to look. And only today did I stumble on the right way to go about finding it. So first, just open the program, open a file. Open a file. My thing is great because it leaves me on the last file that I opened. But that's not the one I opened for that other test. It's an ellipse. Explain. You'll notice that no millions of DLLs got loaded. All that's happening here is stuff to do with my program. Okay, so here it is. I close the program, and lo and behold, I still have the memory leak. I started to narrow it down, and by the end of yesterday, I had narrowed it down to this much. If I open a file, what do I have one? That only has certain types of objects, I don't get a leak. Will this one have it? No. How about here, maybe. Maybe, no, that I'm gonna get a memory leak. But just one, see? Well, also, the memory leaks all have the same, are exactly the same. It's always, you could look at this as a 1 and a 4C1828. If I open that other one, it's going to give me the same number, I bet. Maybe not, though. I'll try a different one. Now, yeah, this will give me one leak. One leak. Oh, no, two. Oh, a whole bunch. But see, it's the same number. 1 and then 4C1828. That was weird. And I count these up. 1, 2, 3, 4 here, I think. Go look at that file, which I don't need to have remembered. It will turn out that there are 4 function objects in this thing. We probably can't see them because some of them might be lines. Like this is a hand-drawn line, but is there just one or maybe two? That's not a function. Alright, well, let's try a simpler case. I made these tests. First I gotta close this. How many have I got? A whole bunch. But I'm going to tell you now that this thing is going to give me 3 leaks. 3 leaks? 2 leaks. 2 leaks. 1 for each function object. Those are function objects. See? Oh yeah, it's not function, it's graphic object. Special kind of struct in this program. I narrowed it down to not the existence of a graphics object, because I can make one. Suppose I make one. Like by drawing one way to make one is to draw a path. Okay, and then move it around. That's a function object. I close this, there won't be a leak, and there isn't. But if I save that to a file, and then load it, then I get a leak. So I draw a path like last time. Just save this. I can call it Alan1 because that's what Alan wants. It's not using my. I don't have a thing for save, but not yet. It's coming. Alan1. Save. Okay, no leak. Now if I open Alan1, right? Same thing as before, I'm going to get a leak. 1 leak only. But if I add in things like arrows and things which are not of that same category, you see how this has helped narrow it down quite a lot. Like a vector. Make some vector with a different thickness, different color. save. There's Allen1 again. Exit. No memory. Oh yeah, I got one. I got the one I had before. If I open up Allen1, I'll get only one memory leak. Okay. And it's because of the line. If I add another line, an example is Allen2, this has two. Well, these are also function. These are of the category function object. I have two memory leaks. Okay. Now, what's interesting as well, I noticed, is that although the allocation number changes every time because there's some randomness, the difference between these two numbers is always the same. So that gave me a clue that it's highly predictable. If I knew where one was, I could find the other. Of course, I still couldn't find one. So now I'm looking at this. In the case of that cardioid, that goes through this I function. How long is this so far? Well, 31 minutes. But this is important. It's important for you to know in particular what's coming up. Here's the loading sequence for one of my types of special objects, special functions, sorry. That one's called a cardioid, this here object. This function, I function load from string, gets called, and that checks to find, it extracts the name of the object from the file. It's a string actually, and depending on which one it is, runs one of these implementation functions, which is just a number defined, which first sets the internal pointer to function to null, and then makes a new object of the specified type, then calls the serialize function for that object, okay, and then does this. Now, I could make it, never mind. Okay, and now then after doing that, the serialize function for the outer object, which is called the TS function, is called. So there's a reversal here that's important to be done in the order that it's being done here. First, the pointer to the object, and then its containing class afterwards. It has to be done in that way for some reason. Anyway, the reasons are irrelevant. Well, now I looked at here at the TS function, the declaration. You can see you can actually declare one of these things. Alright? And I need that. I need to be able to declare one of these things because otherwise I wouldn't be able to do what I have been doing, which is to be able to declare the object first and then run a serialize function on the object that I already have, but I don't know what it is yet. See what I'm saying? I have to be able to declare an object that I don't know what its implementation is yet. Do the implementationing part by reading some data from disk, and then it becomes whatever it becomes. And I noticed this here, MH func, which is a smart pointer type thing. Okay, here, HI function handle to function interface is a smart pointer. And then I remembered that recently, very recently, I made a change in the smart pointer class. Smart pointer, where are you? To change that reference count to start at 1. And I've been terrified about the fact that I've made that change. And now it looks like I'm getting bit by it, right? First, this used to start at 0. I changed it to 1 because of the reasons I've mentioned before, to do with multi-threading. It's not even a necessity for the way I use these things, but just for consistency, I want to make it 1. And that meant I had to make a change to the way this construction order occurs. Sometimes a reference is added to an object, sometimes it's not, right? It's just a bare object. Very delicate and dangerous change. And I thought, for sure, that, I've screwed it up, and that's, it used to work, and it's not anymore. Why is it not working now? It had to be that change. And it might have been that change. However, the truth of the matter is, I had a bug. And the memory leak report, alerted me to the bug. What I did first, this is the important bit, is I fixed it. Okay? I fixed it, and the first I thought, well, maybe I need to do this as an assignment rather than a constructor. And I tried doing it as an assignment. That didn't work. And eventually I just tried doing this. Okay? You won't declare it at all. Let it take the default. Because maybe that's the thing those things aren't getting destroyed. But of course, it's got a new, right? So it should have the file and line number. But believe it or not, this gets rid of the memory leak. This is the point where most people would stop and call it a day and say that they fixed the bug. And I'm telling you that this is not the point to stop and say that you fixed the bug. Because there's no reason why I shouldn't be able to declare that thing the way that I have, even though it's a little bit less efficient. I'm allowed to do that, and I should be allowed to do that. And there are other places in the code, certainly, where I do that. And so by tucking the bug under the rug, tucking the leak under the rug, by removing that line, hasn't addressed the bug. Right? Is it a bug to do with the fact that I've declared it that way? Or is it some other type of bug? That has to be determined. But first I'll show you that this does get rid of the memory leak. And then the question is why? Right? If it's a reference counting thing, why did it not balance out? And at no point did I ever use the smart pointer assignment thing here. It never entered this, right? So it was correctly using this one. and the reference count was, I checked, was 1, as it was supposed to be. That means that the bug had to have been there before. And that the reason the thing got deleted previously, I suppose, must have been just a combination of two bugs canceling each other out. I'm not sure why. If this would just hurry up and build. I hit pause. As I was just explaining this to you, I saw another spot where I think that I've made the same mistake. I've fixed one, and now I think there's another bug. Hang on a sec. Okay, well, that person hopefully will call back. That is one of my viewers. Okay, now where were we? I'm going to show you now that the memory leak disappears when after making that change. Try this one. Exit the program. No memory leak. Great, fixed, right? Well, no. There's no reason why I shouldn't be able to put that line there. Right, here I've declared something that's memory managed, in the sense of it's a smart pointer thing. The allocation doesn't increase the count to 2. It leaves it at 1, which is correct, and there's no reason why I shouldn't be able to do this. And in fact, this isn't that particular cardioid isn't the only function, TS function, that's declared in the program. There are many others, and they're not producing a memory leak. And I can make one and leave the program and I don't get a memory leak. So there's nothing wrong with this. It has to do with the load, something to do with the load. And I looked through the load and how the load works and discovered I found a bug. I put it back, and what I did was, here's the null func. I wonder if I still have it in my history. Oh yeah, first I put this on a separate line, and then what I did was I put constructor destructor traces for this null func to see what happens, just to see, you know, how many get created, how they get destroyed, and so on. One thing, for instance, in the comparisons, these here, oh no, not this one. It's in the, yeah, it's where the actual bug is. Graphics object here, maybe. Somewhere there's an equal, there's another list. And the whole thing is a list of lists of lists. Here's the first, the list of most basic things, either a text control, polygon, line, arrow, collection, graphics collection, these other objects I have defined, and function object, which is the one I'm getting the memory leak on, is the one that where the bug must be occurring. And if I look at this here line, L if type, which has been read in from the save file, is being compared against type name X, where X is, in this case, a function object which has within it okay, it's a color graphics. It has a TS function in it. Okay, so if and I can declare one of these things, and I can get its type name. Its type name is not using the one that the other one that gives memory leaks on purpose. It uses my own type naming thing, crack symbol, which uses undecorate symbol name. Okay. So if I declare one of these things, I can get its type name, and so therefore in my list there, as I'm walking through, I can check to see if the name of the thing read in from the save file happens to be of that type. Okay, by actually creating one. So if this creates a function object, then it's going to build an empty TS function, right? It has to, because it's got one in its list of variables. So therefore, one of those null func things is going to get created in here, right? So there's actually going to be one made just to do that comparison, and it should destroy itself. And if the thing happens to be of that type, then the object becomes a new X, which makes yet another one of those null function things. And in total, it turns out that there should be 3 created, and you'll see that there are 3 created, but only 2 of them get destroyed. And that's a bug. The problem hasn't been fixed. All I've done by not allowing that thing to be a null, TS null func, is hide the bug by not making an allocation. But that's not fixing the bug, that's hiding the bug. If this would, well, this is the second compile, isn't it? It'll be almost done. And then I'll get to actually fixing the bug. Really, I shouldn't have to make a null thing there, right? But it's lucky that it was there because it exposed a bug, which I now have fixed, partly anyway. We'll go to here eventually. Actually, here. Here or well, somewhere anyway. All right. Now I'll load up Allen 1. That has one function object, and here it is. 3 were created. Sorry, too many here. A whole bunch from before. I see 2 destroys. Here's where I'm setting something to null. Okay. Setting hfunc to null is here. Now why do I got so many? Let me clean this file up here. Clear. Call it Allen1 again. There's too much noise in that other one. Alright, now you see 3 creates, and then the set to null and 2 destroys. The one that didn't get destroyed is the first one that was created, right? That one's not in this list. Only the last 2 got destroyed. So one of them was created and was forgotten about. Now how can that possibly be? That can possibly happen if one is doing things like this, like calling a constructor directly, right? Sneaking in a call to a constructor instead of using the ordinary means. It turns out I have very little choice in this case. I've got to get the constructor to run, but this is not the right way to do it. Now, let me just see. Is it in here? No. Somewhere else. Probably in here. I labeled it. I'm so sick. Where's my label? Oh, it's not there. Great. I swear I labeled it. Oh, the wrong Hermite. Okay. Alright, I have to rebuild. Now, maybe that was it then. Instead of setting this to null, let me see now. I checked it in and I checked it out again. This is from long ago. Oh dear. How can they be different? Wrong file? No, I can't remember where I changed it. When I only see one case. Here. Oh no, here. This is the one I changed. I should change the other one. But what I did was, I should have the memory leak back again, right? I put this thing back. The null function. Null function. I did. We saw the traces here, okay? And we didn't get as many deletes as construct. What you should do if you're going to do something like this with an object that's already been constructed, right? This object, function object, has already been constructed. Is you've got to destroy it first. If you want to run the constructor, right? I want to run the constructor with this foo, but in order to do that, I need to run the destructor first because it's already got a foo, right? Not this foo, but this function object contains a foo, mfoo, which is where our missing thing is. And if I do that, then I don't get my memory leak, and the problem is fixed. And in fact, the other place where I'm doing the same thing, I should have a similar, instead of setting that to null, I should run the destructor instead. I'll show you that this works. I'll pause. Okay, now I'm just going to run it, and you're going to see that now with the same code I had previously, I won't get a memory leak. Open Allen 1. Now we got 3 constructs and 3 destructs, and it's balanced, and I won't get my memory leak. Now the problem's fixed. It hadn't been fixed by eliminating the allocation. Now this too, I think, should do the same. This is a something or other which might contain objects that need to be destroyed. And so instead of doing this part, I should destroy the object and then construct it from here, and that should also, this is no longer true, I could put a trace still. Actually, we should get some kind of trace, I think. Let's see what happens. This would be like an I-cardioid type thing. No, I won't get any trace. It won't have a valid it won't have a valid object in it. I don't know for certain. I'm pretty sure that we shouldn't see any extra traces, and it shouldn't crash or anything. And if there happened to, oh wait a minute now. This says TS function. Well, we'll see. I don't see any reason why. No crash. It's the same as before. Exit, and there's no memory leak, and everything's fine. And I didn't have to set that thing to null, right? I simply called the destructor of the object that is partially constructed, and whatever bits of it had already been partially built, anything that might be, following a colon, would be destroyed, and this would recreate them from this other constructor, and everything should be fine. Okay, just thought I'd mention that.